Hello and welcome. I am Musa, and today we are diving into one of the most important topics in SQL, which is sets and joins. And if you've ever struggled with combining data from multiple tables or wondered what union, intersect, inner join, or even left join really means in practice, then this session is for you. We will walk through each concept step by step, using clear examples and visuals from my slides. By the end, you won't just understand the theory, but you'll feel confident applying sets and joins to real-world database problems. So whether you are preparing for a project, gearing up for an interview, or even sharpening your SQL skills, stay tuned, because this session will transform the way you work with relational databases. So this concept will be very, very important for those who are taking data analysis, those who are taking data science, and those who are taking data engineering. And besides that, those who are taking computer science are not left behind. So let's dive in. So we are going to begin with SQL sets. And SQL sets are a set of operations. They are a set of operations that combine the results of two or more select queries. So the queries must have the same number of columns and compatible data types. So in most cases, this is usually the condition. This is usually the condition that for you to be able to combine tables or even combine results from two tables, the tables must have the same number of columns, and then the data types within those tables must be compatible. They must be compatible. So that is a condition. This is a condition. And I'll give an example. When you're having a table that has maybe three columns and three rows, and then you want to join information from that table with another table that contains maybe specific information, the two tables must have the same number of columns. They must have the same number of columns. And then the data types, remember we have different types of data types. We have varchar, we have digits, and so many others. So in this case, the data types must be compatible. They must be compatible. Otherwise, if they are not compatible, then it will be very, very hard for you to be able to join them. So we have different types of SQL sets, which include union. We have union. We also have union all. We also have intersect and except. Those are the different types of SQL sets. And these are the ones that we are going to be speaking about for this session. So let's dive into the first one, which is SQL set, SQL union. And we are going to be using these two tables. We are going to be using these two tables in our activity for today. So the first table, or even table A, is a table that contains information about students. As you can see, we have the student ID, we have the name, and we have the course. And then the second table is a table about the teachers and their courses, the teachers and the courses that they teach. So if you look at the two tables, you can see that the first person is Alice, who is a student, and at the same time, Alice is also a teacher. Sometimes it happens. It happens like we usually have students in their undergraduate studies taking specific courses. And then you also have the same students teaching in the lower levels of education, like the primary levels or even the secondary levels, teaching the same subjects or even the same courses. So you can imagine of a teacher in training. A teacher in training might be taking mathematics or even might be training in mathematics. And then that same teacher might also be teaching some learners in lower levels of learning. So in this case, that is why you can see that we are having some names that appear in both tables. So in this case, we are going to be examining, or even we are going to be querying the data from the two tables and try as much as possible to combine the values within the two tables. Okay, so union combines results from both queries. Union usually combines results from both queries. So in this case, what happens is that it usually removes all the duplicate records. All the duplicates are usually removed. So whenever we use union, or even we use union in our query, what happens is that the union removes, or even the command removes all the duplicate records in this case. So if you have maybe, for example, let me take you back to our previous slide. If you have these two tables and you want to unite the values from the two tables, what will happen is that the output will only contain one value for Alice, because you can see we have two values for Alice. That is, Alice appearing in both tables. So the output will only contain one value for Alice, and the other one will be disregarded. So this is the Venn diagram that shows a representation of this, or of our final output. So our output is only going to have the values that are found in table A and the values that are found in table B. And then it is going to disregard all the duplicates. Duplicates are now values appearing in A, and at the same time they are appearing in B. So the duplicates are going to be disregarded. The output will only contain values from A and B, and then remove all the duplicates. So if you are to run this query, the result of the query would be this. You will have Alice, Brian, and Carol from table A. Those are the students. And then you'll have Evelyn and Frank from table B. So you realize in this case, we have 5 rows. We only have 5 rows. In our tables are 3 rows each. So we are supposed to have 6 rows of values. But in this case, we only have 5 rows because Alice was a duplicate. So in this case, this is our result. Now, one thing you realize is that whenever you use sets, you expect the result to have increased number of rows or decreased number of rows. For example, our students table had only 3 values, and then our teachers table had only 3 values. But in this case, when we combine the results of the 2 tables, what we get is 5 rows. So in this case, there is increase in the number of rows. And then there are some other queries, or even there are some other SQL sets that we are going to be using, and they are going to output maybe less number of rows. So in this case, you expect that whenever you use a SQL set, you expect the result to have either an increased number of rows or even a decrease in the number of rows. Okay, so let us now proceed. And in this case, we are going to select the name and the course of the student, the name and the course from the students table. And then we union the results of the first table with the results of the second table. Within the second table, we are going to choose the name and the course of the teachers in this case, and we are going to union them. Now, these are the specific columns. These are the columns from the tables. The name and the course, those are the columns, and these are also the columns. So these are specific representation, or even a Venn diagram that represents the output. So as I said, we have the output is going to have values from table A and table B, and then it is going to disregard or even remove all the duplicates. So our output is going to have Alice and the course, Brian and his course, and then Carol and his course. And then from table B, we are only going to have 2 values. That is Evelyn and Frank. And the reason as to why we only have 2 values is because Alice was appearing on both tables. So the second Alice is going to be considered as a duplicate. It's going to be considered as a duplicate. Now, I hope that makes sense. So the second type of SQL set is union all. Union all. Now, union all is majorly confused with union. These are 2 types of sets that are usually confused, or even most of the learners confuse them. Union all and union. As we said before, union removes all the duplicates. Union all performs the same operation that is performed by union, but in this case, it removes all, it keeps all the duplicates. It keeps all the duplicates. So you expect that whenever you want to maybe combine results from 2 tables and you don't want to lose any information, what you do is that you use union all. That is what you do. You use union all. If you use union all, then it is going to keep all the duplicates. And this is majorly used in most of the companies and most of the institutions. Whenever you are having maybe names of people appearing as, or even people having the same names, or even maybe the same first names, maybe the same titles, and maybe you're combining results from different tables, maybe from an employer's table and an employee's table, and you don't want to lose information. What you do is that you use union all. So we are going to use our previous query. This is our previous query, but we changed the set from union to union all. I hope you can see that we have changed our query from union to union all. That is what we are using. That is what we are using. So in this case, that will be very, very important. That will be very, very important. So if we were to represent our result using a Venn diagram, this is how our result is going to look like. So in this case, we are going to have values from table A, values from table B, and all the duplicates. So we are going to have all the duplicates. So everything should be shaded in this case. All the values are going to be returned. So union all returns all the values, including the duplicates. So if we wanted the learner's name or even the student's name and the course, and then the name of the teacher and the course, then this would be the output. We have Alice, Brian, and Carol from the student's table, and then Alice, Evelyn, and Frank from the teacher's table. So the output contains all the duplicates. As you can see, Alice has been duplicated. So that is the result. So that is the difference between union and union all. Union all keeps all the duplicates, and union removes the duplicates. Then our third type of SQL set is intersect. It is intersect. And intersect returns only rows that appear in both queries. It will return rows that are appearing in both queries, or even both tables. So what happens is that if you have two tables, assume you have two tables, you have an employer's table and you have an employee's table. And in this case, you want to get values that are appearing, or even names that are found within the employer's table and also found within the employee's table. What you do is that you use intersect. So intersect gives us the values that are found within the two tables. So representing that using a Venn diagram, this is how it would look like. You will have values from table A and table B. Those are now the values that are found in table A, and at the same time, they are found in table B. So in that case, we are looking for this zone, the zone of intersection between the two tables, where the two circles meet each other. That is the zone that we are looking for. So in short, we are looking for values that are shared by A and B. And as you noted earlier, we had Alice appearing in table A, or even in the student's table, and we also had Alice appearing in the teacher's table. So what is going to happen is that when you run this query, the query will output the values that are appearing in the two tables. And the value that is appearing in the two tables is only Alice, who is taking mathematics, and at the same time, Alice is also teaching mathematics. So this would be the result of our query. The result of our query would be this: Alice taking mathematics, or even Alice teaching mathematics. And these values are found in both tables. So you've seen we've used intersect. So intersect basically gives us the zone, or even the point whereby the two tables intersect each other, or even the values that are found in the two tables. And then our next type of SQL set is except or minus. Except or minus. And except or minus returns rows. It returns rows from the first query that are not in the second query. Or even we can say they are usually used whenever we want to get information from the first table that is not found within the second table. So in short, if we want information found in the student's table only, then what we do is that we use except. So we choose the student's name and the course from the student's table, and then we use an except command, or even except set. This is an SQL set. So we use except, and then we select the names and the course of the teachers in this case. So what this query is going to do is that it is going to output the values that are only found in table A and not found in table B, and they are also not shared by both the two tables. So in this case, we are only interested in values that are found in table A only. So this is the logic. This is the logic behind this query, or even behind the output in this case. What happens is that the output would be brought about by picking the difference between the two tables. So it is the first table minus the second table. So you pick the first table minus the second table. It's like we need the values that are found within the first table and not in the second table. So these were the two tables. We had Alice, Brian, and Carol appearing in the first table, and Alice, Evelyn, and Frank appearing in the second table. So the values that are only found within the first table, it's Brian and Carol. Alice is found in the second table. So in this case, our output would only contain Brian and Carol. In that case, that would be the output. These are the values that are found within the first table and not within the second table. Now, if we want the values that are found within the teachers table only, then we interchange the tables. In this case, we interchange the tables. And if we interchange the tables, this is what we are going to have. So we are going to select the name and the course from the teachers table, and then we use an except name and course from students. So we interchange the names of the tables in this case, such that we only return the values from the teachers table that are specific to that table, or even that are only distinct within that table. They are not found within the second table. And this is the Venn diagram. These are representation. We are looking for the values of teachers, or even the values that are specific to the teachers table, or even to the second table only. So as you realized, Alice is appearing in both tables. So the output would not contain Alice. So the output would only contain Evelyn and Frank, because these are the values that are only found within the teachers table and not found within the learners or even the students table. So that is it. So in this case, we can use an except, or we can use minus. They all perform the same operation. So we can use except or minus. Now, as I said, in this case, you can see the output contains only two rows of values. So whenever you use a set, SQL set, you expect the result to have a fewer number of rows or even more number of rows. That is what happens. And then the number of columns in the select query remains the same. If you had selected 2 columns, then your result will only have 2 columns. If you had selected 3 columns, then your result will only have 3 columns. So that is it. That is it about SQL sets. The next in line is SQL joins. And SQL joins are used to combine rows from 2 or more tables based on a related column. That is the condition. That is the condition. The condition is that there must be a column that is related. There must be columns that are related in that case. We must have columns that are related. So we usually perform operations using using columns that are relating the 2 tables. Okay, think of this as matching data across tables to get a complete picture. So most of the SQL joins include, we have inner join, we have left join, we have right join, we have full outer join, we have cross join, and self join. So these are the main ones that are usually used in different industries, or even different companies, or even different institutions. And joining data is very, very important, because as I said, you'll have different tables containing different information within different institutions. Take an example, you're working within the health sector. And in this case, you have a table containing drugs that were administered. You have a table containing the patients. You also have a table containing the prices of drugs. You also have a table containing maybe the charges that were made by each and every, that were made towards each and every treatment that was done, or even operation that was done. And you want to combine all those tables such that you're going to have only one table. In that case, you'll have to use you'll have to use one of these SQL joins to combine all that information. So we are still going to use our we are still going to use our two tables, that is table A for students and table B for teachers. So we are going to be starting with the first one, which is inner join. Inner join. So inner join returns only the values or even rows that match in both tables. So in this case, the condition must be true. It must be true for those rows to be returned. If the condition is not true, then what happens is that the result is usually nulls. So it returns only the rows that match in the two tables, or even in the tables that you've selected. Now, assume you've selected this. In this case, we want to join the students table and the teachers table. We want to join them, the students and the teachers table. And we are joining them on this condition that the cost of the student must be equal to the cost of the teachers. That is the condition. The cost of the teachers and the cost of the students must be the same. So we select the name of the student, the cost of the student, and the name of the teacher. Remember, we use as is an alias in that case. So we are giving this column a new name, student's name. In this case, you can also call it something else. So this is the student's name and then the teacher's name. We want to differentiate the two names because remember from the two tables, the column was only indicated name. So we are using new names to differentiate the names. So this is our Venn diagram. Our Venn diagram represents the values that are found or even that match within the two tables. So we have table A and table B. So the values that match are now A, B. That is a zone that we need, the intersection. This is a zone that we need in this case. So these were our two tables. And let us compare the courses. Remember, our courses must be the same. So if you look at the course, the first two courses in the two tables, math, science, they are the same. Math, science, they are the same. While the third course is different. For example, Carol is taking history and Frank is taking music. So in that case, if we were to join the two tables, then the third row would not be output because in this case, we are only interested in the values that match. So this would be the result of our query. We'll only have Alice taking maths and Brian taking science, and then the teacher's name is Alice and the teacher's name is Evelyn in that case. So this is what you're going to have as the result. You can see in this case, we do not have the third row because the condition was not met or even there was no match within the course column. That is an inner join. We can now proceed to the left join, and left join returns all the rows from the left table, that is the students table in this case, and all the matched rows from the right table. So it will output all the values from the left table and then look for any matches within the right table. If within the right table there were no matches, then the result would be nulls. It would return those rows as nulls or even those cells as nulls if there were no matches. Now we are using the same query in this case, and then we are replacing inner join with left join. I want you to look at that. This is left join. We've used a left join, and then the condition is still the same. So in this case, we are only interested in all the values of the left table and then any matches within the right table. Any matches within the right table. Now, any matches are now those values that are contained within B that match A, and that is our zone AB. So we need A and then AB, and then now those that do not match, which is now the remaining rows within B, those ones will be output as nulls. They will be output as nulls. Now look at this. So for a left join, all these values for the left table will be returned. And then any matching information from the right table would be also returned. If there were no matches, then the result would be nulls for this case. So these two would be the match because math, science, those two are matching, but now the third row does not match. So the result would have this. We'll have Alice, Brian, Carol from the first table, and then the third row as a null. Why? Because the course was not matching. Music and history, they were not matching. So that is why we have a null in this case. That is a left join. And then a right join performs the same or even follows the same logic as a left join. But in this case, the difference is that it returns all the rows from the right table. So it would return all the rows from the right table. That is now our teacher's table. And then look for matches from the left table. This is our Venn diagram. So in this case, the result would contain all the values from table B, which is our teacher's table, and any matching information from table A. That would be now our AB. And then the values that do not match from table A would be regarded as nulls, or even they would be output as nulls. To be nulls, they will be output as nulls. These were our two tables. So in this case, you expect your result to have all the values from table B. That is the right table, because it is a right join, all the values from our right table, and then any matching information from the left table. For this case, the courses were not matching. So you expect the name and the course from the left table to be nulls. And I want you to look at the syntax. We've used a right join. Instead of using a left join, we used a right join. In this case, the right join would return all the values from the right table and any matches from the left table. So this is the result of our query. So these were the values. Remember, we had only selected the name of the teacher from the teacher's table. That is why we only have in one column from the right table. So we have Alice, Evelyn, and Frank. And then from the left table, we have this. We have these values. The two rows are matching. The courses were matching, but the third row did not match. That is why we are having nulls. That is what happens with the right join. And then I hope, guys, you are following up. The next one is a full outer join. A full outer join. And a full outer join returns all the rows from both tables matched where possible. So in this case, it will return all the rows from the two tables, or even from the select queries, the queries that you've selected, or even the tables that you've selected. So it will return all the rows, or even all the results from the queries. And in this case, if the condition was not met, or even if the rows did not match, then the result would have nulls. So what happens is that a full outer join is usually a combination of a left join and a right join, because a left join would output all the values from the left table, and a right join would output all the values from the right table. So in this case, a full outer join would output all the rows from both tables. That is all the rows from the left table and all the rows from the right table. And this is the syntax, or even the query. So we are selecting the name and the course from the student's table, and the name from the course from the teacher's table. And then we are joining that. We are joining that with using a full outer join. And this is it. We are interested in all the values. So if you run that query, what you're going to have is this. You're going to have this. All the values from the left table and all the values from the right table. Now, in most cases, whenever you run, you use a full outer join in your SQL, most of the times it won't work. So for us to simulate that, we usually combine a left join and a right join using a union. So we start with a left join, and then we proceed to using a right join, and then we combine the results using a union. So we have left join, union that with a right join. And what you're going to get is this. You're going to get the same results, values from all the values from the two tables. And then the next one is a cross join. And a cross join returns the Cartesian product of two tables. So what happens in this case, it would multiply the number of rows with the number of rows in the two tables. So for example, our first table had 3 rows. The second one had also 3 rows. So it would pick 3 times 3, which gives us 9. So the total value would be 9 outputs. And this is majorly used when you want to get all the possible. Assume you have a phone and you have different colors, and you want to know the different types of phones that you can produce, and with different types of colors. What you do is you use a cross join, and a cross join would output all the values. So for example, we are selecting everything from the students table, and then we cross join that with the teachers. All the values from the teachers table. And what we get is an output of 9 values. And then, so that is it. So in conclusion, sets combines results from both queries or even both tables. Joins combine results from related tables using a condition. And then they both help us to organize and analyze data effectively. And then to summarize that all, a cross join does not have a condition. It always does not have a condition. So in most cases, a cross join won't have a condition. That is, whenever you're using a cross join, you just have to combine the values from the two tables without setting a condition, because in this case, we are interested in finding all the possible values that we can get from that. And I gave an example. Assume you are having different types of phones. Assume you have Infinix, you also have Tecno, you also have maybe Oppo, and then different customers have suggested different colors. Like most of the customers have shown to be buying different colors of different, I mean, for different fonts. In this case, we have green, we have blue, we have red, and we also have white. So what you do for you to be able to know all the possible maybe fonts that you can produce with different colors, you use a cross join. So in that case, every font would be matched with each and every specific color. If it's Oppo, we will have an Oppo which is green, an Oppo which is blue, an Oppo which is red, an Oppo which is yellow. If it's Tecno, it will still do the same. Tecno which is green, blue, green, or even red. And by doing that, you'll be able to produce all the different colors for all the different fonts, and you'll be able to maybe present what the customers want. Yeah, so that is it. Now, information about sets and joins will be very, very important. This concept will be very, very important, because this is what you're going to be using in analysis of data. In analyzing data, you're going to be using this concept. Joining different tables, you'll also be using this concept in trying to figure out or even to come up with summary, because most of the times in research, you have to get information from different maybe tables, and you have to combine all that information to come up with a specific table that can be maybe used for analysis or even maybe used for a presentation. So these skills are very, very important, majorly for data scientists, data engineers, and even data analysts, and even those who are doing, I mean, those people who are interested in computer science. This concept will be very, very important. And in summary, I think I didn't say this, SQL is all about dealing with structured data. That is data that is structured. It's organized into a specific structure. So when dealing with this kind of data, most of the times you'll use these types of parameters. That is now SQL joins and also sets. For sets, we have 3. I mean, we have 4. We have union, union all, we have intersect and except. And then for joins, we have self join, we have cross join, we have left join, we have inner join, and we also have a right join and a full outer join. So this will be very, very important. So that is the end of our presentation or even our discussion for today. Thank you very much. My name is Musa, and see you in our next meeting. Goodbye.